Hi there everyone, it's Stevens the Skiing Weatherman again with another edition of Weather Weenies. Today we're visiting Catamount on the New York-Massachusetts border on a beautiful President's Day. I'm at the lovely Ski Patrol Shack, and it's a double-decker affair, so if you hear a little rumble from above, it's not thunder, I promise you. I want to do something a little different this week. You know, we've had the same pattern by and large almost the entire winter, and I'm sure you're tired of hearing about the ridge in the west and the trough in the east. That pattern's not going to go anywhere for a while, so we better get used to it. But I want to tell you about some of the reasons why this pattern has been so darn persistent. And I got a little checklist for you over here. First and foremost, El Nino. We have an El Nino in the Pacific, and an El Nino consists of a warmer than normal pool of water. This year it happens to be in the central Pacific, and it was at one time a moderate El Nino. Now, typically when El Ninos get to moderate stage, and now this one's weakening, by the way, and I'll get to that in a moment, but typically with a moderate El Nino, we get colder and snowier than normal in the southeastern part of the country, and we have trouble generating snow in the northwest, and that includes British Columbia. And if you've watched any of the coverage of the Olympics, you know they've been a little snow-starved out there in BC. So this particular El Nino is now weakening. When they start to weaken in December, very often the month of March turns like a light switch and turns into spring in areas where it was cold and snowy, such as the southeast and the mid-Atlantic. But this El Nino didn't start to weaken until late in January and early this month. And that typically means that the cold pattern of the cold trough in the east and the ridge in the west will hold through a good portion of the month of March. I expect that to happen, and it all had to do with the timing of when the El Nino started to weaken and that pool of warm water in the central Pacific started to lose its deviation from normal. It's also shrinking in its aerial coverage. Secondly, the NAO. What is the NAO? That's the North Atlantic Oscillation. And to describe this to you with my magic grease pencil here, I'd have to have a bigger board. But suffice it to say that the NAO, when it's negative, you have high pressure over Greenland and the North Atlantic, you have low pressure over the Cape Verde Islands, which is just off the coast of Africa. And when that happens, the pattern gets blocked. Things can't move as rapidly from the big scale features, large scale features can't move as rapidly from west to east. And we have had a negative NAO most of this winter. The AO is the Arctic Oscillation. That too has been in its negative phase, and when the AO is in its negative phase, you typically have the cold air at the poles spread out and go to the lower latitudes. And because we have a trough in the east because of the NAO, the cold air likes to dive into troughs almost like a receptacle, and that's another reason why the cold air, the colder than normal, has been dominated by this eastern half of the country, and they haven't been sharing that much of it with the west. Volcanoes have played a role in this winter, and I'm not kidding. We don't exactly know the reasons why, but when you have high latitude volcanic eruptions, and we've had two of them in the past 12 months, starting with Mount Redoubt in Alaska, that was just about a year ago in February of 2009, and it was followed by an eruption in late spring by a volcano in northeastern Russia, not that far from the Bering Straits. If the volcano is sufficiently strong enough in those higher latitudes, it ejects sulfur dioxide, SO2, not CO2, SO2, into the higher levels of the atmosphere, and that, for some reason, tends to lead to a negative NAO and a blocking pattern, which again favors the cold in the east. So when those two volcanoes went off in the first half of 2009, long-range weather forecasters were already looking at this pattern setting up for this winter. And last but not least, there's the solar effect. We have been in a very quiet solar cycle for several years now, the tail end of what is known as solar cycle 23. We're just now starting to get some rumors of sunspot activity. We've had some sunspots in the last 4 to 6 weeks, and we think we're in solar cycle 24, but by and large, the sun is still quieter than it is over its long-term average. So all of these things have added up to the predominance of this particular pattern, and as I said, it's not going anywhere for a while. Now, about 10 days from now, sometime during the week of the 22nd, I expect the trough that's been sitting off the California coast, a big piece of it's going to come ashore, and you're going to see another episode of mudslides in California and heavy mountain snows, and that's going to swing through the southwest, bring snow to the southern Rockies and the Sangre de Cristos, the mountains of Arizona, and that impulse is going to go along the southern branch, and there's going to be very cold air in place because about 10 days from now, around the 22nd, we're going to set up a cross-polar flow from Siberia into the eastern half of the country. When that cold air interacts with that impulse coming through the southern branch, the last few days of February, the eastern United States is going to be under the gun for a sizable snowstorm, in my opinion. So anyway, to review, it's the El Nino, the NAO, the AO, the volcanoes, and the solar factor that have led to this pattern being locked in for much of this winter. And the last thought I want to leave you with is this has nothing, I repeat, nothing to do with climate change. Some people would like you to believe that. Nothing could be further from the truth. I'm Herb Stevens, the Skiing Weatherman. Thanks for joining us for another Weather Weenies. Enjoy your holiday week skiing and riding, and we'll see you next week from beautiful Gunstock, New Hampshire. Thanks.